Okay, so let's talk about negative exponent rule and what it means and how do we understand it. So first off, we have two examples, but we're going to go through just the concept to help us gain insight to the rule. So the concept just tells us to think about kind of this expanded form and what it looks like. But if we go back to our quotient rule, right, we know that this means x to the 3 minus 2, which just gives us x to the first, which this situation we can cross f of an x in the denominator and the numerator. It's, anything that crosses out in this situation is equal to 1, so we are left with 1x in the numerator, which we wouldn't write it with the 1 exponent, so this would be kind of the final presentation. Over here, if we kind of think about this in expanded form, just to visualize it, and then we look at it with the quotient rule, we see that we get x to the 0 power. So x to the 0 power, although we were going to go with the negative exponent rule through the concept, this actually allows us to develop the zero exponent rule, right? And it just states that anything to the 0 power is 1. It actually makes sense when we look at this right here, that this concept works very nicely, because what we notice if we use the quotient rule is that we subtracted, we end up with a 0 exponent. But why? It's because when we cross cancel everything, right, it all cancels out. And so ultimately what we're left with is the same thing in the numerator and denominator. And so that's why it, in the end, will be the value of 1, because the numerator and denominator are always the same. So if it's a 0 exponent, it just simply meant that we canceled out those exponents to equal 0, right? So this helps us visualize what happens with expanded form. We end up with 1x on the top, 2 on the bottom, but quotient rule tells us to subtract, which tells us we end up with this negative 1. But if we look, a negative exponent does not make it negative, does not make negative, okay? It's a misconception, or oftentimes an error when kind of thinking through this. But what it does help us visualize is that the negative 1 lets us recognize that there are these x's in the numerator and the denominator, which means that they have to cross out, and I'm left with a 1 left over. So where is my leftover x? In the denominator. So we can add that 1 exponent. So if it is negative, right, it will go to the denominator. Notice that there was no denominator. It will go to the denominator, become positive because of this quotient rule kind of logic, which helps us understand. Of course, we will not put the 1. We'll leave it right there. But then I see in these examples I have negative exponents in the denominator. So how can it be negative in the denominator and then go to the denominator? So it must go to the numerator. And so let's just kind of look at these two problems, and then we'll kind of explain why that might be true. But over here, if we know that 0 exponent rule tells us anything to 0 power is 1, I can kind of cross this off and put a 1 here. Now, I have this 6 and this 2, which are not variables, they are just coefficients, which means I can kind of box them and just think about them by themselves. So I have this 6 over 2, right? And that would just be 3. And then I have a q to the negative 1 power. So we're going to move any negative exponents in the denominator. We'll draw an arrow. So we're going to add that negative 1. We're going to say plus 1. And so I'm going to have g3 plus 1. I moved it up. Then I have this r to the second up top, but I can't do anything to it. But then I have these r's, and I'm going to move them to the top. So I'm going to add 2 more to the r's. So plus 2. So I have this 3q to the 4th, r to the 4th, and then I have this t to the negative 4th. So it's on top, so we're going to move it to the bottom, and so I'm going to add 4 to the bottom, and so over t to the 6th. So this would be over t to the 2 plus 4. Notice this would be our simplest form answer. But let me kind of move this over to the side just so it looks clearer. Q to the 4th, r to the 4th, t to the 6th. And so that's just what happens kind of when we rearrange these equations and move them around. but it doesn't really fully tell us why we move these negative exponents to the numerator, just that we do that. So, well, we'll come back to that one to explain the reasons why, but we have this negative 2 exponent, and it does get distributed to anything that doesn't have an exponent. So I added these ones, just like in the past, and we distribute it. So we end up with this 4 to the negative 2, x to the negative 4, y to the 6, right? We distribute through multiplication over 2 to the negative 2, x to the 4th, y to the negative 2. Now, again, anything that is negative will switch. So I'm going to switch the denominators 2 squared and the numerators 4 squared. X to the 4th here should come to the bottom. I have an x to the 4th down here, so I'm going to add the other 4 to the denominator. And then this y to the negative 2 goes up, and I still have this y to the 6 on top. And I'm going to add 2 to that. So 2 squared is 4. 4 to the 2nd is 16. I have y to the 8th, x to the 8th. But I can simplify these to be 1 over 4, so I end up with y to the 8th over 4x to the 8th, and that is our simplified form. So just to help us get to this concept of why we see this negative exponent go to the denominator become positive, so why does it go to the numerator like we saw? Just quick logic behind that is it goes back to kind of the 6th grade concept. If I say I have a problem like this, 2 divided by 1 over 3. So this is really awkward to look at, so we're going to kind of present it as though we're in 6th grade. So this is a 6th grade concept, but it leads us into this understanding of why something happens in, say, this algebra process. So we're going to rewrite this in 6th grade perspective. We have this, and in 6th grade you were told to keep, change, flip. So why though? Well, this reasoning tells us to keep the 2, switch this, and flip this upside down, which would get us to 6. So why do they do that in 6th grade? Because if we go back to this fraction here, I have 2 divided by 1 over 3. So if I could make this value here, this 1/3, if I could somehow make it 1, then I would have 2 over 1, right? So if I multiply by the reciprocal, I would have 3 times 1 over 3 times 1, which would give me 3 over 3, which would be 1. So if I do it to the denominator, I can do it to the numerator. And now I can see this keep, this change, this flip, right? And of course, we multiply across, so it would be 6 over 1, but that's just 6. So here we get the same thing. And so if I kind of take that and I think about it in terms of 2 over, let's say, x to the negative 3rd power, if I kind of look at this, this is the same thing as saying 2 over 1 over x to the 3rd power if we use the logic over here. And how do I fix that? I just multiply it by the reciprocal on the numerator and the denominator, and that would give me 2 times x to the 3rd over x to the 3rd over x to the 3rd, and of course this just equals 1, so it gives me 2 times x to the 3rd, because anything divided by itself is 1, right? And so that is the logic of why it is, if it's negative, right, if I have x to the negative 2nd, it goes to the denominator and becomes positive. And if I have 1 over, say, x to the negative, I'll use a different number just so it's over a negative exponent, it just goes to the numerator and becomes positive because of the 6th grade concept, keep, change, flip. And that concludes this lesson on negative exponents, which also gave us 0 exponents. And we will stop.